Hey boys and girls, today we will focus on lesson 30, which is adding a mixed number and a fraction. Let's start with section 1. They are asking you to solve 4 problems, mixed number added to a simple fraction. You can see that your denominators, otherwise known as your unit fractions, are the same. So let's start by confirming that you have like denominators, and you're adding 3 1/4 plus an extra 1/4. And what you want to remember is to always take your whole number and transfer that over. And now you are only adding 1/4 plus 1/4. 1 plus 1 gives us 2. You keep your denominator at fourths, and so your answer becomes 3 2/4, otherwise known as 3 1/2. Moving on to C, they have flipped it for you, but don't let that throw you off. You're adding 3/8 plus 5 2/8, which is simply the same as what they did in problem A. You could say 5 2/8 plus an extra 3/8 if you wanted to look at it like that. You want to carry your whole number 5 over, and now you're just simply adding 2 plus 3, which gives you 5. And you want to keep your denominator at eighths. 5 2/8 plus an extra 3/8 more gives you a total of 5 5/8. Go ahead and push pause and continue with B and D. Moving on to part 2, they want you to complete these number sentences. So it is giving you a mixed number plus an unknown fraction and revealing the answer of 5 wholes. Again, you've got a mixed number plus an unknown fraction gives you 5 wholes. 4 7/8 plus how many more eighths will give you a grand total of 5. If you want to look at this as 7/8 plus something equals an extra whole. You have 4 wholes here. On the other side of your seesaw, you end up with 5 wholes, so this equation right here needs to actually end up as equaling 1 whole. So 7/8 plus how many more eighths would give you 8/8. That would be 1/8 more. 7/8 plus 1 more eighth gives you 8/8, which essentially is 1 whole. 4 plus 1 whole gives you 5. Moving on to C, you've got the equation flipped backwards. They give you the answer on the left. So your answer is 3 wholes. And how do you get there? 2 1/6 plus how many more sixths gives you 3 wholes. So essentially you want to find out 2 wholes. That's something you already know. 1/6 plus how many more sixths is going to give you that second 1 whole to get you to 3. 1/6 plus how many more gets you 6/6. That would be 5/6. 1/6 plus 5 more gives me 6/6, which is the same as 1 whole, which equals 3. Go ahead and complete B and D after you push pause. And directions for number 3, use this number bond strategy and the arrow strategy to show how to make 1 whole. All right, so again, this you should recognize as decomposing. When we do a number bond, that is just a fancy way of saying decomposing of a fraction. So you have 2 3/4 plus an extra 2/4. What they're asking you to do is decompose 2/4, because if you don't, you have 3/4 plus 2/4 giving you 5/4, which is an improper fraction. So they want you to take this 2/4 and they want you to decompose it or break it down. So you've got your 2/4 decomposed into 2 pieces, which is 1/4 plus 1/4. You want to carry over your 2 wholes. Keep your 3/4, so we're going to start with our first mixed number, 2 3/4 plus an extra 2/4. Let's decide to take 2 3/4 using the arrow strategy and only add one of these fourths. 2 3/4 plus an extra 1/4, and I'm going to check that off because I've used it, gets me to a whole number of 3. So now, if I were on a number line, I would be at 3 wholes. I take my arrow, I bring my second 1/4 over, and I add my second 1/4. 3 plus an extra 1/4 gets me to a grand total of 3 1/4. Therefore, 2 3/4 plus an extra 2/4 equals 3 1/4. What you would do for B is the same thing. They want you to decompose 3/5 and break it down into 2 pieces. But ask yourself, how many more fifths do I need to get to 5/5 if I'm starting at 3/5? So I'll give you a hint. One of your decomposition fractions for 3/5 will be 2/5. Go ahead and finish B after you hit pause. And moving on to page 2 of problem set, number 4, they want you to solve each of your addition problems in the boxes. And again, let's break down what they're asking us to do. We have like denominators all throughout here. 4 2/3 plus an extra 2/3 would get us to, bring over your whole number 4. That stays. 2 plus 2 equals 4. I keep my denominator, otherwise known as my unit fraction, which is thirds. So I am now going from 4 2/3 plus 2 more thirds gets me 4 4/3. This is an improper fraction because the numerator is bigger than the denominator, so I want to decompose this into 2 pieces. So if I'm taking 4/3 and decomposing it, you always want friendly numbers, otherwise known as benchmark fractions. So 3/3 is essentially a whole. That hasn't gotten me to 4/3 yet. I need 1 more third. So this decomposed becomes 3/3 and 1/3. So all I do now is I take my 4 wholes, I add 1 more whole, which is here. That makes 5 wholes. And I've got this little piece left to add on, and it becomes 5 1/3. 4 2/3 plus an extra 2/3 equals 5 1/3 instead of 4/3, which is your improper fraction. Part B asks us to add 3 3/5 plus an extra 4/5 on top of that. So you take your 3 wholes and bring that over. 3 plus 4 gives me 7. I keep my unit fraction denominator, which is fifths, and now I am at 3 7/5. And this is our problem here, the 7. So I want to take my 7/5 and I want to decompose it. Common sense tells me get to a benchmark fraction that I like, friendly numbers, so I'm going to go 5/5, which is actually 1 whole. How many do I have left from 5 to 7? That's 2 jumps to get to 7. So 7/5 decomposed is 5/5 and 2, 5/5 and 2/5. 5/5 is 1 whole, so 3 plus 1 is 4. And I just take that remaining 2/5 and add it right over there. All right, so you're going to complete C through H in that same way. Go ahead and hit pause. And finally, we have our word problem at the end, which involves solving 7 9/10 plus an extra 5/10. And 2 people did this. Maria thought that she would take 7 9/10, and her way of adding 5/10 to that was to take 7 9/10, add 1/10 to get to a whole of 8, and then 8 plus 4 more tenths gets her to 8 4/10. So that is Maria's answer. Paul thought that he wanted to take 7 9/10 plus 5/10, and that became 7 14/10, which became 7 10/10 plus 4/10, which got him the exact same answer as Maria, 8 4/10. And your question for final answer sentence is, explain why Maria and Paul are both right. So they're telling you right off the bat that the way that Maria's strategy happened for her, it worked, and they're also telling you that Paul's strategy worked for him. You have to show your work and figure out why they are both correct and explain that. So if we look at Maria, she took, this is the original problem that both Maria and Paul had right here. 7 9/10 and 5 more tenths. That did not change. What changed is the way that they solved it. Maria took this 5/10 and she distributed it. She took, of the 5/10, she took one of those, 1/10, and added it to the 7 9/10, which got her to a whole of 8. And then she distributed the rest of the 5/10 after she did the 1/10, which left her with 4/10. And she distributed the 4/10 over here for a grand total of 8 4/10. Her answer is correct. What Paul did, Paul took the 7 9/10, just like we did earlier in the problem set, plus the extra 5/10. He went ahead and added 9 plus 5 to get 14 up here, and he kept his denominator. So now he has 7 14/10, and as we learned earlier, he's got an improper fraction here. He's got 14 in his numerator. Now he breaks down and decomposes 14/10. He decomposes that into 10/10, which is 1 whole right here, and 4/10 is what he has left over, which is right there. So he takes 7 14/10, and it becomes 7 plus 1, which gets him the 8, and the extra 4/10 left over is right here, and he ends up with the same answer that Maria has. Why are they both correct? They're both correct because it doesn't matter how they split up the numbers. So restate this sentence and your answer becomes, they are both correct because it doesn't matter how they split up the numbers. Okay? The order in which you add is also not important, just so you know. They are both correct because it doesn't matter how they split up the numbers.